Malin Holzmann is my name. I'm an obstetrician at Karolinska University Hospital in Stockholm, Sweden. And I collaborate with my colleague Farhad Abtahi, who is an engineer also at Karolinska Institutet and the Royal School of Technology in Stockholm, Sweden. And this pairing is the point of our talk today. We want to show you a problem this community here knows very well, and we go through some evidence of how large it is. And we will show you a draft tool, and this is round 0. We bring it to this room, and we would really like your feedback. So CTG is, as we know, the most widely used method of interpartum fetal monitoring in the world. And it has over 50 years of research behind it. We have the visual, traditional interpretation, computerized analysis, and now AI and machine learning. But here's the uncomfortable part. Studies that claim to measure the same parameter often measure different things. And the pipelines and the definitions differ. And they differ in ways that the paper you read never tells you. So the same recording can give you totally different numbers depending on choices that me as the reader or the interpreter cannot see. So we know that visual interpretation of CTG varies substantially between observers, with a kappa for several of the CTG parameters between 0.2 and 0.4. Some of the parameters are better with a higher inter-observer variation quality. But the computation of the data, it quietly adds a second silent layer on top of this. This is not bad science, but it is invisible science, and we believe it can be fixed.
Or at least we can try. So I see that Antonio was laughing a little bit because the first time that I was in a spam, I think it was in Munich, and it was forced. And then I asked if there is any plan for such a activity, making a checklist or some guidelines. And then I remember that she says, yeah, we have talked about it many times. And then I learned that, I also learned from the Amy's attempt last time, that is a very hard work. So I gave up. But then we discussed it also during the last few days. With all these new tools that we have, like AI agents, many of those activities, they can be more efficient. So we don't need to do this kind of activities the same way that we would have done it 10 years ago. So that's why we have started. So the whole core idea is that every CTG number or feature that we are reporting is actually end of a chain of the hidden choices that we make. And perhaps it's a start from acquisition, if it's from Doppler, or if it's from a real fetal ECG, what are the sampling frequency, which devices is being used, even if you go more details, which firmware of the device was used. You can also talk about, for instance, the pre-processing, how the filtering was done, what is the interpolation that they did, and all the augmentations activity that you could do. And then perhaps I don't go to the details, but perhaps all of us know that when we talk about baseline, we don't have so much agreement. There are many, at least if I remember, 11 plus baseline methods. For the STV is also more than 9 different STV formulas. And then we have variations, how to extract different features like acceleration and deceleration and so on. And perhaps it comes also to the outcome or the clinical outcome, and perhaps there is no agreement about that, which is all fine. There is no, I would not say there is a wrong decision or a wrong choice, but the problem is that there are hidden choices. So, and is more clear when you see actually the papers that they go through different journals, some of them more technical and some of them perhaps more clinical, and then by chance you might get some CTG experts that ask you to report some or not, and then there is a lot of variations that we have. So here, if we mention about the short-term variation, all of us we have tried to do it before, and perhaps there is one name STV, but then, as we all know, there are many different formulas how to calculate it. And not all of them are just problem for the scientific papers, but sometimes it can actually go even down to the clinical work. Malin has an example in this case.
Yeah, that's exactly what happened in my labor department. We, before the truffle study, we worked with the old sonic aid machine, and we noted the STV threshold reported by Street and Dawes in the 90s, 2.6 and 3.0, as markable risk factors for intrauterine death and metabolic acidosis at birth. And then we moved into new hospital buildings, and parallel to the physical move of patients and staff and all gear, the head of department and the MTA and administrative staff decided, let's buy new machines, and because they are so old, the old ones. And we clinicians just assumed it would be the same STV as we always were used to. And so we didn't ask, and the manufacturer didn't report any other thing either. And the first night on call, my poor colleague, who was the senior on call, why are all our extreme preterm, threatening preterm births or severe preeclampsia that we are trying to wait as long as possible and time the best point of birth, why are they all now at marked risk for acidemia or even intrauterine death? Should I run and C-section them all? And it can't be right. And we had the old straggling machine that was on its way to die, but we brought it along, and we saw they reported completely different STV. And so this was really the moment where we could have unintentionally, it would have been an iatrogenic extreme preterm birth with all those risk factors due to this problem.
Yeah. But perhaps the STV is not the only problem. So the same story can go for next. Yeah. So the same story we can say about other parts. Perhaps we know that, for instance, in the case of STV, we had some discussion yesterday about how we can underestimate the STV values if you are using the Doppler instead of the ECG. We know also about for instance, for the pH prediction, how it's collapsing from almost 0.9 to 0.26 when we are using 900 Hertz sampling frequency for fetal ECG, or using the 4 Hertz when it goes to 4 Hertz for the sampling rate. So we have all these variations that they are actually very important. So, and they are actually going to change the whole knowledge that we are producing from the perhaps papers, but also for reproducibility of what we are doing. So,
yeah. And I've already talked about why this can matter a lot in the clinic. They are not just small details. They will have consequences in our clinical work. So these hidden choices decide what the result actually means. And when they stay hidden, several things become impossible. We cannot reproduce an analysis. We cannot compare results across studies, devices, or items, or sites. And we cannot know whether two studies even measure the same signal or are trained on the same outcome. So that makes it very difficult for me as a clinician who will be responsible for the medical care and choice to trust an AI model whose inputs are unspecified. And I cannot translate it safely to the bedside of the patient. Yeah.
So perhaps intuitively, probably we agree about this problem, but what I did try is not actually a systematic review per se, but I tried to see if I can actually see the pattern a little bit more systematically in the papers. So what I did, I tried to find 800, I found around 800 papers from PubMed and also even from the Open Archive for the preprints that are more recent. And then I try to exclude the one that they were not really about the CTG because there was some, or the one that they were review. And then I came down to 50 because that was the number that I could alone dare to look at the papers. So in those 50 papers that I tried to select from different different fields. Some of them they had AI, some of them they were traditional reporting of the STV or decelerations and so on, and some of them actually just from the machines. I tried to make 29 items that I was creating for myself, to be honest, because when I'm looking at what we did publish before, then I'm saying that, okay, we could have reported more. And then I was trying to make this list for ourselves. And then I had these 29 items. And then I tried to see if these 29 items, I can actually find them in those papers. And it was two main questions. Did they mention it at all? And if it's enough to rerun the experiment that they did, or if it's enough to retrain the same, for instance, AI algorithms. And as you can see, 66% they were actually at least mentioning it. But if it was enough to rerun it, it was going down to just 36%. But if we look more details here, I think the best part was actually about the outcome. I think it was, don't take the numbers, but yeah, let's say more than 60% with my own judgment. More than 60% they had reported. But then when it goes to reproducibility and access to the software or code, it was dropping dramatically. So it was going down to almost 5%. So it might not be exact numbers, but at least it shows the pattern, I think.
Yeah. And so we see this as a problem, and our suggestion will come in next slide. I just want to be clear that this was not just our idea. Yeah, you remember last year, Amy Lovers is not here this year, but she did huge work putting us all together, a lot of co-authors from this room in this paper in BJOG last year, where we set our priorities for better interpartum care with minimal and shared data standards, open and documented algorithms, federated learning, and harmonized outcomes. So we do not want to compete with that, just complement it. And we believe we need a transparency layer, a clear way to report what we've actually done, so the share data and share algorithms can really be compared. For anyone who might be less familiar with the reporting guidelines, this is a solved problem for many other fields. We have a CONSORT already in 1996 that was a checklist that you should use when you report a randomized trial. And after journals endorsed it, 25 out of 27 items were reported more completely, so it was very successful. And in 2003, the STARD checklist came for diagnostic accuracy. And in 2015, we got the tripod for clinical for prediction models. And in 2024, there was a tripod plus AI with 27 items adding pre-processing, calibration, and fairness for machine learning models. And then in 2025, the tripod LLM for the pattern large language models. So extending a general framework to a specific technology is a proven pattern, but none of them covers the CTG signal pipeline. So that is the gap.
So here is our proposal. There are two proposals. One is for the RCCTG, or reporting checklist for computerized CTG. And another one is the extension for the tripod, so few items to add to already existing AI checklist. The items that you see here, 72 items, 13 domains, or 26 items for 9 domains, they are actually just the round zero that we are bringing to the table. And then the idea is that we can come up with a consensus about those items that we have to keep or merge, or maybe we need to add new items. I'm sure that among all the knowledge that we have in this room, there will be possibilities for improving this checklist. And the idea is that they are going to cover the whole pipeline from a clinical context to the study flow, signal acquisition, and all the steps that you already know. So I'm not going to take your time for repeating. But yeah, the process, perhaps each item is going to carry its own weight, and it's going to be the motivation for each item, why you need to report it, what is the best maybe example of how to report it, and perhaps we can also have some common failure or how it should not be reported if it's possible. So this is maybe too ambitious, but maybe it's possible. So we will see where we can get. So here is one example of some of items in 2 domains from our draft of round 0. And you can see that, there will be some description, what should be reported, and maybe motivation or how it should be reported as well. So as I mentioned, it was these 29 items that I started in the step 1. Now we are in step 2. We are having just first draft. And the idea is that we are going to have this e-Delphi, I would call it. And that's what makes me dare to start the process. Because if we want to have different experts from different countries to be in the Zoom meeting or in a Teams meeting with all the busy schedules that all of you have, perhaps it's impossible. So we are going to be happy with this e-Delphi that is been possible to do very good with the new tools that we have. The idea is that you will have access to a platform that you will see each item. The idea is that we are going to have if there is an item that is more than 70% rate between 1 and 9 for the importance, if they are between 7 to 9, and more than 70% of reviewers, we will keep it inside. And if it's not important by 70%, we will leave it out. And perhaps otherwise we will actually keep it for the next round. So maybe by time we can actually add few items, or we will remove few of those items, and the next round will be less work for you to do. So here is on the left is the platform that is with the, perhaps you can recognize the Cloud Code doing. So you can actually have report the importance of each scale or each item. You can actually have propose to accept or accept it with some minor wording. You can actually propose some major revision. You can merge with another item or propose the merge. And you can also report if you want to remove it from the checklist. And perhaps there is an optional part. For instance, I know that some of those items, they might feel too much when we want to write. So behind this scene, we will try to make this consensus.
So that's it.
Okay, very good. Just to have a minute or two for questions.
Yeah, it's just a draft, and it's open for discussion.
Right. Any questions, please? Right, okay.
Excellent presentation. I think it's such an important thing that we need for the field. My question is really simple. How do we contribute? What's the best way to get in touch? Yeah.
Of course, we would be happy to that everybody who's interested can actually express the interest, and we have already discussed with few of you, and perhaps if you are you are lucky or not lucky, you will receive invite, because I think it's going to be a lot of work. So it's if you are happy to contribute, we are going to be very happy to get to have you. So
Excellent. Sounds
exactly,
great.
exactly.
Really appreciate this work, because I think, reproducibility is a major problem in the field of machine learning broadly, and because we are also using in healthcare decision making or supporting decision, is very important to address this. I was wondering how, because there's always the conundrum that, sometimes the data comes from a specific device, so it's tied to a company, and then there is a difficulty in making that, let's say, open source, which is what you already stressed, that the minute you went to reproducibility, the numbers dropped. That also means publishing a source code is also getting challenging. But also, if we write all details, the paper length becomes like 50 pages. So so how do you suggest?
I don't know if you have seen the tripod AI, for instance, usage is not supposed to be part of. Not everything is supposed to be part of the paper itself. So it's a appendix or supplement that you attach the perhaps checklist. So not everything is supposed to be in the main body of the, perhaps depends on the journal. So it might be not interesting for the audience of that journal, but you will have it as an appendix. So.
Okay. Yeah, thank you. Yeah.
And perhaps it doesn't mean that if you don't have it, you cannot publish, because maybe you can report why you cannot report that item, for instance.
Right. Okay, I have one quick question. This variability coefficient you reported in the beginning, 0.2 to 0.4, does it mean 20 to 40% of the cases may result into different outcome? And how was this calculated?
I actually published a paper using the kappa inter-rater variability, but it was so long ago I cannot explain it. It's not the percentage, actually. Not exactly. But anyway, and that was actually, we're worst at being assessing the variability the same. We're best at baseline and accelerations. I would say, yes, regarding the visual interpretation. Yeah.
Okay, thank you.